let us see about stream ciphers. So a typical stream cipher encrypts plain text one byte at a time. Although a stream cipher may be designed to operate on one bit at a time or on units larger than a byte at a time. In a stream cipher, a key is input to a pseudo-random bit generator that produces a bit of that produces a stream of 8-bit numbers that are apparently random. And the output of the generator is called a key stream. So this key stream is combined one byte at a time with the plain text stream using the bitwise exclusive OR operation. So stream cipher is similar to one-time pad, and one-time pad, as you know, it is a genuine random number stream, whereas a stream cipher uses a pseudo-random number stream. So they are similar, but they are not the same. So one-time pad makes use of a genuine random number stream. Okay. So here, as the formula for creating a ciphertext is mentioned. So Ci is mi XOR the stream key I. Okay, the randomness of the stream key completely destroys statistical properties within the message, making the adversary impossible to find out the new possibilities of the keys that can be generated given the previous keys. So this figure here illustrates the stream cipher structure. Yes, you can see on the left hand side there's a key that is being input to the pseudo random number bit generator, and there is a plain text byte stream also being XORed with the key that is being sent. Encryption happens and the output obtained is a ciphertext for that particular byte stream. And when XORed again, when the ciphertext byte stream is XORed with the key again, then the plain text byte stream M can be obtained at the receiver side. So now let us look into the properties of stream ciphers. So these properties are well designed based on certain important considerations. So the encryption sequence should have a larger period or a longer period such that there are no repetitions occurring. Okay, so this makes because more repetition means more access by or more brute force attack by the hackers. So this should be avoided. Therefore, no repetition is the key. Then the key stream produced should be statistically random. They must be independent to one another and they should be unique in its own way. So the more randomized the ciphertext, the more difficult it would be for cryptanalysis. Then to guard against the brute force attacks, the key needs to be sufficiently long. So the same is applicable for block ciphers as well. So with the current technology, a key length of at least 128 bit is desirable. So with a properly designed pseudo-random number generator, a stream cipher can be as secure as a block cipher of 128-bit key length. So the primary advantage of stream cipher over block stream is that they are always faster and they require less coding than the block ciphers. So a stream cipher can be constructed with any cryptographically strong pseudo-random number generator. So stream ciphers are simpler and they're faster. So in this session, we will also look into a very popular example of a stream cipher algorithm, namely RC4. So RC4 is a stream cipher designed by Ron Rivest for RSA security. So RSA, if you remember, it is a asymmetric encryption algorithm, and it has been developed by Ron Rivest, Adelman, and Okay. Okay, and here the RC4 is a proprietary cipher owned by RSA DSI. So it is a variable key size stream cipher with byte oriented operations. The algorithm is based on the use of a random permutation. The analysis of RC4 shows that it works fine for any variable key size byte oriented stream cipher applications, and therefore it finds wide applications in wireless uh, networks, as well as in uh, the web applications that make use of the secure shell and the secure socket layer and the transport layer security. Now, the key forms the random permutation of all the 8-bit values, which addresses a permutation to scramble the input information processed a byte at a time. So the cryptanalysis of the RC4 shows that there is an overwhelmingly striking rate of 10 power 100 combinations that is possible in RC4. So 8 to 16 machine operations are required per output byte, and the cipher can be expected to run very quickly in software. So RC4 is probably the most widely used stream cipher, and it also has a trade secret which is maintained by the RSA security. And during the year 1994, it was anonymously posted on the internet uh, on the Cypherpunks Anonymous Remailers list. So RC4 key is used to form a random permutation of all the 8-bit values. It then uses that permutation to scramble the input info processed a byte at a time. Now the RC4 key schedule, it is remarkably simple, and it uses a variable key length as shown here, ranging from 1 to 256 bytes. So RC4, so here, the most important uh, part of the RC4 algorithm is represented here as a pseudocode. So as you can see, variable key length of size ranging between 1 to 256 byte is applied here, and the RC4 key initializes the state S, that is, which is given here as S of I. It is being initialized um, into a number between 0 to 255, and then it walks through each entry in turn using its current value plus the next byte of key to pick another entry in the array and swaps their values over. So here you can see, so T of I is so K here refers to the key. So extending of key happens here, I mode key length, and then for 0 to 255 repetitions for each element, the swap has to be updated, and therefore that it is given here as J plus S of I plus the T of I, the extended key, mode 256. And then the swap function is mentioned here. So during the swap function, the permutation is also happening. So the total number of possible state here is 256 factorial, okay, which is a truly enormous number. And in this way, maximum key allowed can be selected. Now, let us check upon how encryption process is being carried out in RC4. To form the stream key for encryption or decryption, RC4 continues to shuffle the permutation array S by continuously swapping each element in turn with some other entry. So here the sum of these two entry values are used to select another value. So that is showcased here in the pseudocode. And so here you can see it is being, so Ci here is created from Mi XOR S of t, right? And yeah, so XOR S of t with next byte of message to encrypt or decrypt. So, stating about the security of RC4, it is claimed to be secure against some well known attacks, and based on the analysis, it has been able to recover multiple keys or same plain text attack. Because of its non-linear nature in securing the applications, they are of high popularity. And being a stream cipher, it is not required to reuse the key. So next is a graph which showcases how key handling is being carried out for wireless applications where WEP protocol is initiated. So here in the x-axis, you can see the size of the key increasing. Okay, so as the key size increases, the performance is, the randomness of the randomness and the strength of RC4 is also equally increasing. So the time taken to break the RC4 ciphers is also possibly it's being impossible as well. So the probability of recovery of plain text from 2 power 24 fiber text versus its byte stream is quite difficult. So a more serious problem occurs in its use while in WEP protocol, not with RC4 itself, but the way the keys are generated for use as input to RC4. So currently RC4 is secured, but probably with a sufficiently larger key. So a quick summary about this, the session that has been held today. So first, we came across why pseudo-random numbers are chosen in cryptography, and the randomness has to be created from pseudo-random number generators. And we saw three categories of pseudo-random number generators. One is true pseudo random number generator, second being pseudo random number generator, and other form of pseudo random number generator being the pseudo random function. So PRNG, PRF as well as TRNG. And then randomness requires independence, and they should be unique. It should not be repeated. So there are various properties that also we learned along with the random numbers. And then shortly there we saw what stream ciphers are. So in stream ciphers, a stream of plain text data is collected as bytes of data, and then it is XORed with a key stream. The key stream here being a random number key stream would eventually result in a highly secured stream cipher. And we have seen the properties of stream ciphers as well. So stream ciphers are result in faster, you know, when it is being applied in applications, the results would be faster when compared to the block ciphers. And RC4 is a very popular algorithm which is used for the creation of stream ciphers. And we also came across the various key schedules, the encryption process of RC4 as well. So the entire content has been referred from the fifth edition of Cryptography and Network Security book by William Stallings. And this session, this contents for the session is taken from the chapter Stream Ciphers and Random Number Generation of the same book. So, thank you.